Hey, what's up everybody? In this video, I'm going to walk you through the solution to number 6 from the 2025 AP Calculus AB free response questions. Number 6, we have an implicitly defined function, and in part A, we are to show what the derivative is equal to. So when we're showing our work here, we just do the derivative with respect to x of y cubed minus y squared minus y plus 1/4 x squared equals 0. So taking the derivative, you would have to use implicit differentiation. So that'd be 3y squared times dy dx minus 2y times dy dx minus dy dx plus the derivative of 1/4 x squared is going to simplify to 1/2 x equals 0. And then what we do is collect all the terms with dy dx on one side, terms without dy dx on the other. So we would subtract the 1/2 x to the other side and factor out dy dx from the left side. Be careful, this term, when you factor the dy dx, you still need a 1 there as a placeholder. So dy dx equals negative x over 2 times 3y squared minus 2y minus 1. For part B, there's a point P on the curve G near 2, -1 with x coordinate 1.6. Use the line tangent to the curve at 2, -1 to approximate the y coordinate of P. So we have the point. In order to get the tangent line, we also need the slope at this point. So what we're going to do is evaluate dy dx at the point 2, -1. Plugging that in, you would have -2 over 2 times 3 times -1 squared minus 2 times -1 minus 1. And that's all going to simplify down to -1/4. So our tangent line is going to be y equals the y value plus the slope times x minus 2. And then we're going to plug in x equals 1.6. So -1 minus 1/4 times 1.6 minus 2. That's going to give us -1 minus 1/4 times -0.4. And this simplifies all the way down to -0.9. Part C, for x and y both greater than 0, there's a point S on curve G at which the line tangent to the curve at that point is vertical. Find the y coordinate of point S. Show the work. In part C, you have a vertical tangent line when dy dx is undefined. And that's going to happen if the denominator is equal to 0. So 2 times 3y squared minus 2y minus 1 equals 0. So we would have to factor this. Since 3y squared, since 3 is prime, you would have to have a factor of 3y and y. And since the last term is -1, the last would have to multiply to 1, so they would have to be 1 and -1. Since the middle term is -2, this one would have to be negative and this one would have to be positive. So we would have y equals 1 here, and this would give us y equals -1/3, but we can eliminate that because in the problem, it said that both x and y have to be greater than 0. So we have our y coordinate of 1. And finally, part D, a particle moves along curve H defined by the equation 2xy plus natural log y equals 8. At the instant when the particle is at the point 4, 1, dy dt equals 3. Find dy dt at that instant, show the work. Now part D switches gears a little bit because here we have a implicitly defined function as well as related rate type of situation. So our function is 2xy plus natural log y equals 8. We're going to differentiate this with respect to t, so you treat x and y both as functions of t. So for the 2xy, you would have to use the product rule. So derivative of the 2x would just be 2 times dx dt times y plus 2x times the derivative of y, which would be dy dt, plus the derivative of natural log y, which would be 1 over y times dy dt, equals the derivative of 8, which is a constant, which is 0. Now we know the point is 4 comma 1. We also know dx dt equals 3. I recommend plugging these values in first and then solving for dy dt. So you would have 2 times 3 times 1 plus 2 times 4 dy dt plus 1 over 1 dy dt equals 0. So you can combine some things here. 2 times 3 is going to give us 6, plus the 2 times 4 is going to be 8 dy dt, and then this is going to be 1 more dy dt. So you would really have 9 dy dt equals 0. So dy dt equals negative 6 over 9, which is negative 2/3. And there you have it. That's it for this video. Thanks for watching. And if you like this video and it was helpful, give me a like and share a comment below which problem on the AP exam this year was most difficult for you. And if you're not subscribed, please do so, and you'll always stay up to date with my most recent videos.